Welcome back to Stewart Science. Today we're going to be talking about the different sources of error in an experiment. So what I'm going to do, I'm going to give you 4 of them and then one that you should never ever use. But before I even give you that source of error, I want to give you an example of what this looks like when you do it in a lab in an incorrect way. So here's the first example. I'm going to do an experiment for you, and I want you to pay careful attention to what I do, how I measure, and maybe even what I choose to measure with. So the experiment that I'm going to use in each of these cases is that I'm going to be rolling a paper wad down the ramp and measuring how far it gets from the ramp. I will change the number of books underneath the ramp so that it ends up at different angles from trial to trial. Now, if I was going to do this really well, I would need to do each height 3 times, and I would need to change the height 8 times. I'm not going to do that for this video because I don't want it to be that long. So pay careful attention to what I do. So here's my first mistake. So I've taken off one of the books, and now I'll run it again. And then I would measure, and I would call it 48.9. I took off another book. Here we go.
Third trial.
And I would call that 32.2. Pause the video and think, what was my mistake? In that example, what you saw me doing was dropping that paper wad differently each time. I changed both the height of my ramp and how I dropped the paper wad. And so since I changed 2 things, that means I had 2 independent variables, which means I have no idea which one of those is truly responsible for my result. Bad experimental design is the first source of error in an experiment. Here's another example for the second one.
Here's the second mistake I made.
I'm going to measure it with this 1-foot ruler. It's 3 feet. It's 1.8 feet. $1.6 feet. In that example, you saw me using a measuring tool that was both the wrong unit and had no markings. So that tool did not give us the ability to take accurate or precise measurements. Here's another example of something else that you could do wrong. So now I have a good experimental design. I'm going to make sure that I only change one thing, and that's ramp height. So I'll drop it the same way, and I'm going to measure with a good tool instead of this one. Good tool, good experiment. We'll see what mistake I make. It's about 1 meter. It's about 45 centimeters. It's about 82 centimeters-ish. What mistake did I make? In that example, you saw me using a good meter stick, but I wasn't using it to its fullest ability. I was not using the tick marks on it. I was just estimating about where it ended up on the meter stick. So this is good. I'd say the biggest opportunity for you to make a mistake in your experiments is to use a good tool, have a good setup, and then use the tool wrong to take inaccurate and imprecise measurements. You have to make sure that not only do you have a good experimental design and a good question and a good setup, and you execute your experiment right, not only do you use a good tool, but you also use that tool in a good way. So using your tool wrong is going to be probably your biggest source of error in your experiments. Here's the last example. For this last example, it's best if I don't change the height of the ramp to demonstrate the issue that you may run into in future experiments. So let's pretend that I'm taking 3 trials at the same height. and we'll see what issue I run into. Sorry, 62.8 is my measurement. Now notice I used the right tool the right way when I measured this. Let's try it again. That one only went to 33.7. That one went to 88.2. So you'll notice those three numbers that were at the same height for the ramp are very different. We had one in the 60s, one in the 30s, and one in the 80s. Those numbers aren't anywhere close to each other. They're all over the place. What issue do we run into? In that example, you saw me roll the paper wad the exact same way. I used a good tool, and I used it right, but I didn't get the same results each time. That's because the way my experiment was designed just did not let the same result happen 2 times in a row. Sometimes the paper wad slid down the ramp, and sometimes the paper wad rolled, and so the result is an irregular response, that my responding variable just didn't have the same response each time. So since my paper wad was not a regular shape, it was an unpredictable result, so it's inconsistent, and therefore we couldn't draw any conclusions for it. Now, here is the final thing I want to say about sources of error. A lot of times I see students call it human error. Do not use the phrase human error, because human error is just a cop-out that says I don't want to truly think about what caused the errors in my experiment. I want to just use a bucket, catch all, and call it a day. If you are a human, you make mistakes, but you make mistakes in one of the 3 or 4 ways above. Either you messed up in your experiment or how you did your experiment. Either you didn't use a good enough tool to measure your response, or you used a good tool and you took inaccurate measurements from it. So those 3 things are going to be where your human error is. Never, ever, ever use the phrase human error. It's not a thing. It's a lazy cop-out. If I ask you to think about your errors, or if your teacher asks you to think about your errors, they want you to look back at your experiment and imagine the ways where it could have gone wrong. That way you know what to do if you were asked to go take better, more accurate measurements. So again, those 4 things are bad design or bad execution, using a bad tool to measure, using a good tool the wrong way, or just not having a good, consistent phenomenon that you're looking at. Never use the word human error. As always, this is Mr. Stewart. Keep learning no matter what.